Okay, this lab is called Graphing Periodic Properties. I'm going to start you off. You do need to have a periodic table, this worksheet, and then also this piece of graph paper that was given. You're going to be graphing two graphs. One graph, it's already labeled. It's called the atomic radius graph. Radius has to do with the size of the element, and the other graph is ionization energy, which has to do with energy that the atoms have. You guys have your periodic tables, and they should be labeled. Ionization energy, it increases as you go to the right. So as I go to the right, okay, you get more ionization energy. So if the question asks, what has more ionization energy, nickel or zinc, what would you say? Zinc. Okay. And with the atomic radius, it says it on the side, but as you go down the periodic table, the atomic radius increases. So the size of the element is getting bigger. So if you had a choice between magnesium and barium, which one has the larger atomic radius? Barium. And which one would have the smaller atomic radius between cesium and rubidium? Rubidium would have the smaller atomic radius. So those are called periodic trends. That's what your next exam is over as well. I'll start with the introduction. The periodic law states that when the chemical elements are placed in order of increasing atomic number, their properties repeat in a periodic manner. So it's predictable. In this exercise, elements numbered 1, hydrogen, through 20, calcium, will be studied by graphing their atomic number and different properties, the atomic radius and ionization energy. So you will need two different colors. So here's the pre-lab. Use the information in these tables to complete the graph as described below. We'll do that, but let's start over here on this side. So across a period, okay, from left to right, what's the trend as you go across the period? The radius does what? Does it get bigger or smaller? Yeah, gets smaller. Or you can write decrease. So as you go left to right, it decreases. But if you're going right to left, that's when it's going to increase. So that's what the arrow you should have on your periodic table is. Energy, does energy increase or decrease from left to right? Increase. And electronegativity increases as well. So the ionization energy and the electronegativity do the same thing, always. That's the pattern, okay? They're always going to be going in the same direction of increasing and decreasing. The only one that does the opposite is the atomic radius. So you could say the relationship between ionization energy, electronegativity, and the radius, they're inverse of each other. If one's going up, the other's going down, okay? Down a group, the atomic radius does what? As you go down the periodic table? Increase. Good job. What happens with the ionization energy and electronegativity as you go down? Yes, decrease. They do the opposite. So they do the opposite. Okay, the procedure, it wants you to orient the graph paper. We actually made the graph paper already ready for you to go. So I think it's going to give you the steps to do the x-axis and y-axis, but we did that for you already. Here's your data table that you're going to graph. Okay, here's the atomic numbers, and the atomic radius only goes on the atomic radius graph. Okay, so if you take a look at this graph paper, you have two graphs, the atomic radius and ionization energy. The atomic radius numbers only go on the radius graph. Okay, does anybody have any questions on that? And then the ionization energy would go on the ionization energy graph. And you're just making a dot line graph, and you're going to connect the dots. One thing I do want you to do though is on the graph paper where it says number 1, write the symbol for number 1. So the symbol for number 1 would be H. And you might want to write smaller. I'm just writing it a little bit bigger so you can see. The symbol for atomic number 2, He. The symbol for atomic number 3, 4, and so on. So you're going to do that for both graphs, for the atomic radius graph right here at the top, and for this graph down here, the ionization energy graph. So after you go ahead and plot your graph, you're going to see a pattern, okay? And you're going to read your graph and pull information out from it. If you guys need help, you can call me over. But the questions that go with the graph are in your conclusion. And then you can either do it right here, or you can do it on the back, or if you need more paper. Okay, you need to have this component in your graph, or I'm going to take off 20 points. That starts you at an 80. Okay, this is going to be your conclusion on what you took from the lab. Not everybody's CER will be the same. Okay, this is your claim. This is your evidence. And this is your reasoning or rationale. And I can help you on that. More than likely, everyone's evidence will be the same because you can say, according to the graph, you can tell, you know, where certain patterns are happening. And everybody's claim can be different, okay? Doesn't mean you have to have the same. If you need help with that, you can go ahead and help me, or I'll help you. And that's it.